Very good morning. Myself, Dr. Himadri, Assistant Professor of Department of Electronics and Communication Engineering at the Institute of Technology. Today I am delivering the lecture on operational amplifier. Before I go through the details of this op-amp, the content of the lecture is like that: introduction, what is op-amp, the circuit symbol, picture, pin diagram, important terms and equation related with that of op-amp, properties of the ideal op-amp and non-ideal op-amp, characteristics of op-amp, and different applications and their advantages and disadvantages. So, in introduction, as we know that the name is that operational amplifier, basically doing some or it performs some operation such as arithmetic and logical. Arithmetic is addition, multiplication, division like that, and logical means and or not. This can be performed. So that's why basically this is called the amplifier with a special name operational. It doing the or it perform the operation such as arithmetic and logical. A brief history that in 1947 it started from its journey of op-amps with that of vacuum tube, first developed by the John Ragazine, and then after in 1960 Fairchild Semiconductor Corporation's and Robert Wheeler fabricated op-amp with the help of IC fabrication technology. Means as the technology is developing, so in 1968 Fairchild introduced the op-amp that was to become the industrial and commercialized standard. So op-amp basically a DC coupled high gain voltage amplifier. Direct coupled high gain amplifier usually consists of one or more differential amplifier. So output stage is generally a push-pull or push-pull complementary system pair basically. So op-amp or differential amplifier, it's basically the whatever we apply in the two inputs, it taking the difference of these two. So the output voltage is proportional to the difference of the two input voltages. The op-amp symmetric symbol basically is actually shown here. Input, two input, one is inverting, another one is non-inverting. The minus sign is shows that is the inverting input, and plus sign of the input shows that it is a non-inverting input, and the output is shown in there. And for operating, there is a input voltage is required to operate this op-amp. This is plus B and minus B. The two is there. Already I have told that why it is called operational. Basically, amplified. The amplifier which could be confined to perform the various operations, including addition, subtraction, differentiation, integration, means logical and arithmetic operation. So op-amp is basically multi-stage amplifier. Basically, it's one kind of multi-stage amplifier used to number of amplifier stages interconnected in each other to complicated manner. And as a result, we just giving our input and output. We are getting output. In between there, so multi-stage amplifier circuit is there. The symbol is there already. I have told that. A block diagram is of the op-amp is shown here basically. There is a four stage are there: input stage, intermediate stage, level shifting stage, and output stage. Basically, this is the two input, inverting and non-inverting, and this is the output. In between there is a four stages are there. So basically, this consists this four stage means input stage, intermediate stage, level shifting stage, and output stage. In case of for to satisfy for input stage, the input stage must be satisfy the following requirements, such as it must have two inputs, inverting and non-inverting. It must provide a very high input impedance and low output impedance. It must be directly coupled amplifier and have a very high CMRR, common mode rejection ratio is abbreviated as CMRR. An intermediate stage. Then the next stage is of the after input stage, that is intermediate stage. In intermediate stage, basically gain of the output is specified here. So the requirements of the intermediate stage are moderately high input and output resistance, high voltage gain. Then go to the third stage, that is the level shifting stage. Due to the direct coupling between the first two stages, the input of the level shifting stage is an amplified signal with some non-zero DC level. Level shifting stage is used to bring the DC level to zero voltage with respect to the ground. And the final stage is that output stage. So to satisfy this output stage must be followed that criteria such as low output resistance, large current sourcing capacity, and large output voltage swing. So this is a picture of a very initial op-amp, and now it is modified in IC configuration with 8-pin IC. So that is the evolution from initial stage to the present state. So pin diagram of a 741 op-amp IC is shown here, basically 8-pin IC. So pin number 1 is basically offset null, pin number 2 is the inverting input, and pin number 3 is the non-inverting input. Pin number 4 and 7 are used for the power supply. Plus 7 is the plus voltage source and 4 is the minus voltage source, and pin number 6 is the output, and pin number 8 is no connection. So a few terms that are related with that of op-amp, such as input bias current. What is input bias current? The average current flow into the inverting and non-inverting input terminal of the op-amp. This is basically known as the input bias current. And input-output impedance, it is the resistance offered by the input and the output terminals to vary the voltage. This quantity is expressed in the ohm. Basically, resistance or impedance is resistance, so that's why it's expressed in ohms. Open loop gain, it is the overall voltage gain of the amplification or of the amplifier. The fourth is that the input offset voltage. It is the voltage that must be applied between the two terminals of the op-amp to null the output. Means output should be zero for the particular input. So that is called the input offset voltage. Input offset current, the algebraic difference between the current into the inverting and non-inverting terminals. This is known as the input offset current. Another term that is related with that of operational amplifier is known as the virtual short or virtual ground. We know actually the grounded, that is the actual ground. So what do you mean by that virtual ground? Or what is the concept? How can we get that the term, the virtual ground? This non-inverting terminal of an op-amp is connected to the ground. Then due to the virtual short or existing between the two input terminals, the inverting terminals will also be grounded. Means potential is grounded, there is no current sinking. Okay, hence it is said to be a virtual ground. During that time, we can say that this terminal is also called a not actual ground, but it's virtual ground. There is a potential is zero, no current sinking. So next we go through the configuration, closed loop configuration, open loop configuration and closed loop configuration of the op-amp. So open loop means there is nothing feedback is connected with that of input to the output to the input. Closed loop, in closed loop configuration, some kind of feedback. Basically, this is the feedback term is known as the output is entered. Some portion of the output is entered into the input terminal. That path is called the feedback. When feedback is connected in the circuit, then this is a closed loop configuration. It may be positive or maybe negative. So, on the basis of the terminal, which terminal the output is entered into the input, on the basis of there is two type feedback: positive feedback and negative feedback. So, positive feedback, if the feedback signal or the output of the op amp is entered in the positive terminal of the op amp, this is the known as the positive feedback. This feedback used basically for amplification such as oscillator and Smith trigger. Negative feedback, if the signal fed feedback into the input of the inverting terminals or negative feedback. This is also in negative terminal. This is also called a negative feedback. Okay. So there is a 180-degree phase difference with that of input and output. So the circuit diagram is shown here. The output, some portion of the output entered into the input. That is the negative terminal. That is the negative feedback. When it is entered into the positive terminal, then it is called as a positive feedback. So, op amp in different configuration can be used in as an inverting amp mode, non-inverting mode, adder, subtractor, integrator, voltage follower, differentiator, and so many instrumentation amplifier can be used. Here we just for clarification, we just saw the inverting and non-inverting mode. Inverting mode, the circuit diagram of inverting is shown here. The input is applied in the pin number 2. Okay, and a feedback portion is come and entered into the negative terminal. So this is the circuit diagram of a inverting amplifier. So inverting means whatever we are applying input, the output is in the just 180-degree phase shift. That can be visible from the input and output waveform. Okay, input and output, there is a phase shift, clearly visible that there is a phase shift, and obviously a gain is appeared in the output. So that gain is defined by these two resistance R1 and R2, feedback and input resistance. This is a simple calculation. From there we can finally, we are just not explaining the calculation. We get the gain factor AV, that is minus Rn by R1. That is the feedback resistance ratio of the feedback resistance with that of input resistance. From there we get a gain factor. Whatever the applying input, the output must be amplified factor of this gain factor. The negative sign here actually, that is indicating a phase shift with that of input and output by a 180 degree. That's why the output is in the out of 180 degree phase shift with that of input. In non-inverting, just biasing is applied in the non-inverting terminal in the pin number 3, and feedback is also coming to the 3. So there is a calculation gain factor for the non-inverting, that is 1 plus Rn by R1. So the value we are getting, that is plus sign or positive sign, that indicates input and output are in same phase without closed loop is always greater than unity. Okay, so that's mean in a same phase. That is the difference. That is the circuit diagram for non-inverting. The feedback is connected with the negative, and input is applied in the positive terminal. This is the input and output waveform is shown here. It is clearly visible that input and output waveform are in the same phase, but output is gained by a factor of 1 plus R by R1. So that's why the amplitude of the output is more with compared to the input. So ideal op amp. We know the minimize the loading as well the design voltage amplifier must draw a negligible current from the input source and must present negligible resistance to the output load. Op amp are known as the ideal. So what are the characteristics of a op amp? Got two different modes, open loop and closed loop. Already I have discussed that. Open loop configuration, there is absolutely feedback present, and for closed loop, so this is the few important characteristics of an op amp that such as infinite voltage gain, infinite input resistance, zero output resistance, infinite slew rate, infinite CMRR, infinite bandwidth. These are the few characteristics of an ideal op amp. Zero power supply rejection ratio, that is often abbreviated as ESR, okay. And slew rate is infinite. So characteristics of ideal op amp, the infinite input impedance, its value may be 2 mega ohm. Low output impedance, that's mean nearly 200 ohm. Very large voltage gain at low frequency. Infinite common range mode rejection ratio CMR. Infinite power supply rejection ratio. So these are the ideal characteristics of ideal op amp. But those who are non-ideal characteristics, these are the few characteristics of non-ideal, like finite open loop gain that causes gain error, or finite input impedance, non-zero output impedance, and finite CMR, common mode input resistance, finite bandwidth, finite power supply rejection ratio. That is the difference, the characteristics changes with the ideal and non-ideal. So just in a tabular form, I have shown there a few characters, applications of op amp in linear and non-linear and wave setting circuit. In case of linear circuit, integrator, differentiator, log, adder, subtractor. For non-linear applications, comparator, zero crossing detector, amplitude distribution analyzer, Smith trigger, clipper, damper. For wave shaping, sine wave generator, monostable multivibrator, bistable multivibrator. These are the different applications on the basis of linear, non-linear, and wave shaping circuit of the op amp. Yeah, just even few examples such as A to D converter, means analog to digital converters. From symmetric diagram, it can be visible that analog signal as an input, there is a 8 DC analog to digital converter, then passes through the digital system, then again it converted to the digital to the analog converter, and output is given from a speaker. Okay, so that is the input signal, that is the digitalized, and again that is the output signal. So for that conversion analog to digital, operational amplifier is also part of that. It can be also act as a current source. Here it can be clearly visible that the input terminal is connected with the inverting terminal, feedback is there, and the non-inverting terminal is grounded. So it can act as a current source. Zero crossing detector applications. So circuit diagram of a zero crossing detector is shown here. Inverting is grounded and non-inverting terminal is input is applied. So basically, it basically used to check whether the op-amp is in good condition. Okay, that's why it is applicable. Zero crossing detector is applicable to find out its performance, how it is look like, a good op-amp or not. Zero crossing detector can be used as a frequency counter and also for switching purpose in power electronic circuits. GCD is basic of op-amp, means GCD means zero crossing detector is a basic of op-amp circuit. So, what are the advantages of this operational amplifier over the conventional amplifier? It has smaller size. It's a big factor because as the technology is progressing, so the size area specific and size is one of the main factors. Its reliability is higher than that of the conventional amplifier. Also, cost for commercialization, cost is one of the factors. It's reduced cost, less power consumption, easy to replace. Same op-amp can be used for various applications. Means one op-amp can use in different applications, few linear, non-linear, and wave shaping circuit. It can be used. And finally, thanks for the basic of the to deliver the lecture on the basic of the operational amplifier.